Okay, in lecture 2, I'm going to be giving you a very basic example again. This one is going to be a heat transfer example, and what I'm going to do is one directional or 1D conduction example. In this lesson, what you're going to learn is modeling, in which I'm going to just draw a very simple rectangle, a simple rectangle, and then you're going to learn how to do a mesh in ANSYS, during which you're going to learn how to use line size and free meshing of an area. And after that, you're going to add thermal loads, which are going to be temperatures only at the both sides of the rectangle that I'm going to be drawing in the modeling section. And then basically we're going to solve this example and read the results which we require from a simple 1D conduction heat transfer. So the example is going to be something like this. It's going to be a rectangle. I'm going to give a length of 10 units to this length, and a length of 5 to this side of the rectangle. For the conduction constant K, I'm going to give 100 units, and the temperature on this side I'm going to give 100, and the temperature on this side I'm going to give, let's say TH here and TC in here. I'm going to give 20. And as you see, I'm not concerning myself with the units yet. We can discuss the units later as the course progresses, but so far let's just focus on the numbers and not focus on units, because the first important thing, or the most important thing in learning ANSYS, is how to do your modeling and do a mesh and run the analysis. So the conduction heat transfer equation is basically minus K times delta T over delta X, if this direction is going to be our X, and this is one dimensional, right? And we're assigning this minus in here because we know that temperature or heat transfers from higher temperature so from here to here. So heat conduction or heat transfer is going to be in this direction. So T2 is going to be equal to TC, and T1 is going to be equal to TH, which means T2 minus T1, which is equal to delta T, is going to be negative. That's why we assign this negative sign in here. So in other words, Q is going to be 100 minus 100 times 20 minus 100 over 10, which is going to be 100 times 80 over 10, which is going to be 800 units. And the direction of heat transfer, as I said, is going to be in X direction. But because the length and the Y direction is small, 5, if we do the analysis in ANSYS, you will see that there is going to be some heat transfer in Y direction as well, in this direction. But this is just a demonstration, so I'm not gonna focus on the length in Y direction. I'm just gonna give you a very basic example on teaching you in these three concepts in an analysis or FEA analysis with ANSYS. So basically this is the example, a very simple rectangle in size, length of 10 and 5 units, conduction constant of 100 and the temperatures of 120 at both sides of this rectangle. And the other thing I want to talk about is the length or the meshing. So I'm going to divide this bigger line, these two, by 10 elements. So when I'm doing the line size and during the meshing step, I'm going to divide these two lines by 10, and I'm going to divide these two lines by 5, so the length of each element here and here and here and here is equal to 1 unit, which will mean that I will have 10 times 5 elements. So when I'm done with meshing this area, I will get 50 elements that will be used to do the analysis. Well, this is not perfect. I can divide these lines into smaller segments, hence increasing the number of elements for my analysis. But then the result will be more accurate, but then it will take longer time to do the analysis. For this example, it will not take that long if I divide each of these lines to 150. But since this is just an example, I'm going to stick with 10 and 5 to just show you how everything works. Okay, let's switch to ANSYS and run the analysis in here. The first thing I want to do is to make sure that what I have, or what I will see in the future in this analysis, is going to be only thermal. So I'm checking this option in here, and I click OK. And I go to the preprocessor, choose element type, and I want to add an element. Click Add, and I see thermal mass. Come to Solid. And I want to pick 8 node, which means that each element that I will have after meshing will be containing 8 nodes per element, and this element is quadratic, as you see in here, which means my elements are going to be square in shape. So square with 8 nodes. I'm going to click OK. Plane 77 is a name that ANSYS gives to this element. Click Options, and you will see this window. Specific heat matrix is consistent, and element behavior is going to be plain. I'm going to stick with the defaults, so I OK this window, close the previous window. And this element does not need any real constants, but let's just give it a try. Add Edit, add for the element plane 77, OK, and this window says that the plane 77 element type does not require real constants. Close these windows, and the next step is to define the material properties. So I click on Material Models, and what I will see is this new window, which is different from structural in that the properties that I can define from a material in here will be only thermal properties, and so this window does not ask me for elasticity or Poisson's ratio. The only thing that is asking me is about conductivity. So I want to have an isotropic material, so I click this, and there is only one requirement or input that I have to provide for the software, and it's KXX, which means the conductivity in both directions, X, Y, and even if I have a 3D model, it will be X, Y, and Z. They're all the same. So I'm going to give the conductivity of 100. Click OK, and my material is made. I can close this window and jump to the modeling section and create an area, and I want to create a rectangle. I'm going to use by dimensions. So when I click this by dimensions, you will see this window pop up. So I just have to give the coordinates in the beginning and final coordinates in X direction, and beginning and final coordinates in Y direction. So I'm going to go from 0 to 10 in X, and from 0 to 5 in Y directions. Click OK, and my rectangle is made. The next step is to do the meshing. So I come to the mesh, and as I said, I wanted to use size for lines. So I click the size control, and I want to do manual. So I click manual, and I want to change, or not, I want to divide each lines on the sides of this rectangle into smaller segments. So I click lines, and I click picked lines. So for the first, I pick this one and this one, the lines on the bottom and top, click apply, and in this window I say for a number of divisions, make 10. Click apply. So as you see, these lines in the bottom and top are divided into 10 segments. Now I pick the lines on the left and right, click OK, and change this one to 5. Click OK, and my lines on the left and right are divided by 5 smaller sections. Now I run mesh, areas, free, select my area, click OK, and my area is meshed by 50 elements. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 50 elements that are going to be used to do the analysis that I'm requiring, or I want to do in this example. So the next step is to define the loads. The first thing I want to do is make sure that I'm doing a steady-state analysis, because my temperatures are not changing by time. So I click OK on this window, come to define loads, go to apply, thermal, and temperature, and I want to define temperature of 100 units on the left side and 20 units on the right side. So I click on line, pick this line, apply, temperature of 100, click apply. This mark tells me that the temperature on the left line is defined. So I click the right line, OK, and change the temperature to 20, and click OK. So now my model is ready. So I can go to Solutions step and pick Solve Current LS, and click OK on this window, and solution is done. I can close this window and close this window. So now we can jump to the general post-process step and read some results. So in plot results, if I click counterplot, nodal solution, nodal temperature under DOF, click OK, this graph or this plot shows the temperature difference from the left to the right. And red is the difference between 91 to 100, and the blue is changing from 20 to 28 or 29. Because my number of elements were a little bit small for this analysis, the temperature gradient is very abrupt. So from 100 to the other lower temperature is changing very abruptly. But if you had divided the lines into smaller sections or segments, for example, if I had divided the top and bottom lines to 100 segments instead of 10, then the accuracy of my analysis would increase. But because, as I said, this is just an example, I'm not going to concern myself with number of elements. I just want to show you how everything works. The other thing you can think, or you can look for is, let's say, thermal flux and X direction. And everything is in red, which means in X direction we have a constant heat transfer of 800 units as we had calculated before. But the interesting thing is, because I have a small length in my Y direction, there is some heat transfer in the Y direction, which is pretty random. So in heat transfer, the basic idea is that if you want to have 1D conduction, then the length in y direction should be very long. But for my example, the length in y direction is pretty small. It's half the length of x. But since this is an example, we can forget about that one. The other thing that I want to show as the results that you can acquire from this analysis is vector plots. Go to predefined and thermal flux, click OK, and this is the vector at which your heat transfer is taking place in x direction, and the value is 800, shown here. Now let's do something with select, how you want to select number of nodes, not necessarily all the loads or all the nodes. In list results, there is a command called nodal solution. You click it and you define what you want to read. I want to read temperatures for every node, so I click OK. And initially you see that the temperatures of all nodes are given to me for 181 nodes that were generated after meshing. But what if I want to see the temperature, I want to read the temperatures for all the nodes on this line, the bottom line. So I come here and I click select entities. This new window pops up. I select line, and I can select lines by num or pick. I click this one, click apply, and this window pops up, which means that I can pick a line. I do this, click OK, and so this line is selected for me. And then I come here again on select entities. This window pops up again. I click nodes attached to lines. So the basic idea is, now that I have selected one line, ANSYS knows only one line out of this whole model, and that is the line that I selected in the previous step. Now if I select nodes attached to lines all, this means that select all the nodes attached to the line that is known by ANSYS and all the nodes. The difference between this option and this option is, if I pick lines interior, the nodes at the beginning and end of this line are not going to be selected. But if I pick, so with this one, the only nodes inside the line are going to be selected. But if I pick lines all the lines that are attached to this line, all the nodes that are attached to this line are going to be selected. So if I do this and click OK, and come to this nodal solution again, in the same temperatures, and click OK, as you see, only the 21 nodes that are attached to this line are presented to me, and their temperatures are reported. So if I want to pick let me do something in here, numbering, and I want to show the numbers for nodes. I check this option, click OK. So you see only one line is shown to me, and the numbers for nodes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on till 21. And you notice that ANSYS is not showing the number of odd nodes in here, or the numbers for the odd nodes in here, because it would be a little bit crowded, so ANSYS is avoiding that craziness. So only one line is selected, and all the nodes that are attached to that line are selected for me, and I'm seeing the heat transfer associated with that line. If I want to select all the lines again and all the nodes again, just come here under select everything, nodal solution, nodal temperature, OK. Back to the previous one. All the nodes and their temperatures are reported. Come back to here again. The whole model is shown to me. So this is the end for the first lesson, or for the second lesson. I hope you enjoyed this one, and I will try to teach more with more advanced examples in the future.